Consider the node with its well-defined inputs, with its well-defined outputs, with a prompt field, with a model field, a server, an API key. What are these inputs? What is this output? What is this anynode? Hello everyone and welcome to another episode of Stable Diffusion Experimental. Today we'll be taking a look at the incredible anynode. It is a node, but it is also the node and can be any node. Anynode was released less than a week ago, and it is a node that can do anything an LLM can do, because inside of it there is an LLM. Or well, not inside, but we'll get to that later. What is an LLM? An LLM is a large language model, and if you are in the space, of course you know about Gemini or ChatGPT. There are also some other nodes that can implement LLMs inside of comfyui in order to help with, for example, prompting or captioning images. So using LLMs inside of comfyui and Stable Diffusion in general is not exactly a new concept. So what sets any node apart from any other LLM nodes out there? Well, any node is a node that can do anything. On the GitHub, we can see some implementations of this node. In this example here, it starts from an image and it creates an inverted Sobel filter in order to create a sort of line art of the image. But it can also start from a video, for example. It can separate an image into channels and then output something by manipulating those channels. It can write, it can solve math, it can manipulate images in order to get different generations out of them. Now, some of these things, of course, are doable with specialized nodes, like in this example where I am manipulating the RGB channels of the image. We could just separate the RGB channels with an RGB node. But there's also some things that it can do that other nodes can't. Like for example, these past few weeks I have been looking for a blending node that could have linear light blending options. And there was no node like that to be found, at least I didn't find it. But by asking any node to blend the two images together that I've been using as an input based on a linear light mode, it created a script that could handle linear light blending. Now, how does that work in practice? Well, the first thing you need is to install the anynode custom nodes. You can find them on the manager, or you can git clone from the GitHub repository. You will find that in the description below. Then you will need one of two things. You can either use it with API on a remote connection with openAI or Gemini. So if you're in Europe, most likely you're going to end up using openAI, or you can use it with a local LLM installation. In my case, I am using Llama 3 on Ollama. And that means that there are no costs involved. There is no API key usage. If you want to stick around for the explanation of how it works, I will show you later how to install a local LLM at the end of this video. So now, in my case, I am working through a local LLM. The LLM is up and running, and what I need now is inputs and outputs. Any node can accept any kind of inputs and will output any kind of output, as long as the output makes sense based on both the inputs and the prompting. So in my case, for example, I could use a load image node, connect it to the input, and if I want to manipulate the image into another image, what I would do is just drag and drop and search for a preview image node. In this case, it will look like this because it's not suggested. There is no suggestion to make here in the output, because it could really be anything. I am going to choose an image, for example, of these flowers, and what I want to do in the prompt field is give the LLM instructions about what it needs to do. Let's start with an easy one, for example. The first thing we have to do is describe the input. In this case, it's an image. But since we're working with tensors and not images inside of Stable Diffusion, I will have to specify that this input is a tensor that represents an image. So the input is a tensor representing a RGB image. And then I will give it an instruction. For example, take the input, separate the RGB channels, and output the red channel as an image. And I'm going to hit qprompt. The connection has been made and it's starting to calculate the kind of code that it needs to implement in order to solve the prompt. Now we are getting an error. And this is a feature, not a bug. And this may be hard to understand, but the way the LLM works is that sometimes it will encounter errors. But the LLM, with each Q prompt generation, will try to fix its own errors. So we want to take notice of the error, in this case cannot handle this data type, close it, and hit Q prompt again. We have the same error, which means that the LLM cannot solve this. So there might be an issue with our request. We have asked to output the red channel as an image. Maybe we can rephrase that. Let's delete that and say the output should be a tensor representing an image where the red channel is set at strength equals 1, the green channel is set at strength equals 0, and the blue channel is set at strength equals 0. Let's hit Q prompt again, and there we go. Here we have the resulting image with the red channel that has been set at strength equals 1. Now, those of you that are working with images already know that this request is different from the original one. I cheated a bit. And that's because the red channel as an output only is a black and white image, whereas this is the image if the other channels beside red were set at a strength that equals 0. In the original prompt, I wanted to get the black and white image of the red channel, but with this one, I'm getting an image where the blue and the green channel are at strength 0 instead of 1. You can see where this is going. Prompting correctly is the key to get this anynode node to work. Okay, so we want to change the prompt, and we want to say that the output should be a tensor representing the red channel only. Hit Q prompt again, and there we go. We have our black and white image that is the red channel. Now let's take a look at what's happening in the background in order to understand better. Here's my terminal where comfyui is running. If we scroll through it, we see some text. Every time we hit Q prompt, a set of coding instructions is injected into the LLM in order for it to get the job done. In this case, it's this thing over here. Your job is to code the user's requested node, given the inputs and desired output type, etc, etc. It's giving the LLM also examples, like image tensors come in the shape, batch, width, height, RGB channels, so that it can understand what an image is, it doesn't get confused. And it also has an example generated function in Python, so that the LLM doesn't get confused about what Python code is. After all of that, the LLM starts writing code. In this example, it starts by importing torch, and then we have the actual code to separate the channel and give back only the red channel. The way this node works is that every single one of these nodes has a memory. So if it fails at providing code and throws an error, if you ignore that error and hit Q prompt again, it will try to fix itself based on the previous iterations, at least up until the point where it finds an error it cannot solve. And since it has a memory and it doesn't understand that it can solve the issue if the issue is solvable, what you would need to do is just erase everything here by copying and erasing everything, and then hit Q prompt again, which erases all of the memory if the prompt field is empty, and then paste back your text and then hit Q prompt again. Now it's working basically in real time because of another feature, and that's the registry. Now this is a fun one. During the first day that I had been trying my hand at this node, I got in touch with the dev and they were so great. I reached out to them on their Discord and we jumped on a live stream session by them, and we got to talking about what this node could do and couldn't do, and they were telling me about how this node memorized things, and I said, okay, that's great. But, well, if I were to release a workflow to my public, their own instance of this node wouldn't remember anything. They would have to start from scratch. And being based on an LLM, I don't know if their node would find the same solution as mine did. So what the dev did was create a solution out of the blue in, I think, 2 hours tops that could store the solution to the prompt that was used and use it as long as the prompt in the text field was the same that was used in order to find that same solution. So now it's possible to ship out workflows that use anynode with a sort of pre-existing memory of what they are doing. Now, of course, there are some limitations to it. The first that comes to mind is that the issue that the LLM is trying to solve can be solved by using Python code. If the issue is not solvable with Python code, then the LLM can solve it. Then the LLM needs to be able to write proper code, and the code needs to have no errors. Now, if you have ever tried to code with ChatGPT, for example, you know that LLMs are great at making you believe that they know how to write code, but they really don't. So most of the time, they are forgetting about importing modules, or they make some errors in some lines of code. But the great thing about this node is that the LLM will eventually try to solve its own code. And so, although it is a random procedure, it can solve stuff even if you don't know how to code. And the third limitation that we were talking about earlier is that the LLM needs to not get stuck in front of a wall. Now, the wall might be real or otherwise, in the sense that something might not be solvable by Python code, or the LLM might just think that it's not possible to do so and can't recognize the error. So you will never know for certain unless you are a dev whether it's just the LLM not reaching the desired conclusion or the solution cannot just be found with Python code. But apart from these three issues the LLM might have, this node could really be any node. Now, if you remember the workflow from the previous video, the one where we start from a photo, create a virtual set in 3D, relight the picture and preserve details and colors, you will probably remember that I've been having issues with the frequency separation technique because I was locking a couple of nodes, one for linear light and one for apply image. But since the anynode has solved by itself the lack of a linear light blending option, I can just take it from here, where it learned how to solve for linear light, and place it in my workflow, like it's doing over here. Now, of course, the image is not perfect because I am still missing the apply image blending option, but if I get another anynode to understand that I need that blending option as well, I could just chain them together and solve the blending issues. So if your workflow is missing any kind of nodes that you can't find, anynode could solve that issue for you, at least as long as it's codable in Python and anynode understands how to do that. But in my case, it's not like I even need two anynodes to work together, because anynode can solve complex functions. In my case, I could ask it to do the whole frequency separation technique by itself, and if it can come up with a Python code that can do that, it will do that. But that's the hard part about this node. Thinking about what already exists is one thing, but thinking about what is not there and it's doable, that's a difficult thing to do. But once you get to actually solving something that wasn't there in the first place and anynode could do, there's no feelings like it, really. I was doing a live last week on Friday and we solved the linear light blending option with anynode while live, and it was a great moment. It was me saying, yes, I'm trying to do this linear light thing with anynode, but it seems like it can't solve it, and then I just hit qprompt and boom, it did just that. So now, for those of you who don't know how to set up a local LLM, let's go through that quickly. It's very, very easy, but it all depends on your hardware. You need to have proper hardware in order for this to work. You want to head over to Ollama. You will find the link in the description below, and you want to download Ollama. You can choose the platform of your choice, in my case that's Windows, and you are going to download an executable file, an .exe file. You're going to double click on it, install it, and you want to open your terminal and write Ollama serve. This is going to start the server for Ollama, and the default address is 127.0.0.1, and the port is going to be 11434. Now, in my case, of course, it's already running, so there's no need to serve it again. And after that, in order to use a model, you want to run Ollama run and then the name of the model. Now, how do you know the name of the model you want to use? Well, in my case, I am using a Llama 3, but you can find all of the models here in the models sections. And here you can find all the different models that you can use. Now, not all of them are great at doing what comfyui is doing. In my case, I've been using Llama 3, Mistral, and Lava. So now we want to write in the terminal, Ollama run Llama 3. Now, in my case, I have already downloaded it, so it's starting up without downloading it again, and I can chat with it like I would with a normal GPT. So for example, I can ask it, are you happy? To which it will probably say that it's an AI, so it doesn't have emotions like humans do, but we are not here for that. We can hide away our terminal and we can go back to comfyui. And inside of comfyui, all we need to do is specify the model. In my case, that's Llama 3. The server is turning on, so in my case, that's HTTP localhost at 11434. And the API key is set at Ollama. And if everything goes right, we can just hit Q prompt and it will work. And for the case of using anynode with external LLMs, you can just double click and search for anynode, and you will be able to find two different nodes, the standard one for OpenAI and the Gemini one. But in order to use these two nodes, since they don't have any API key field here, you have to refer to the README file on the GitHub, where there's two cases, one for OpenAI and one for Gemini. For OpenAI, you need the OpenAI module installed, so you can run pip install OpenAI and then add your OpenAI API key to your environment variables. And there's a link to do just that. Or for Gemini, you just need to add your Google API key to your environment variables. Now, you have to be wary of that this node sometimes downloads stuff that it thinks it's useful from somewhere else. So in my case, it installed at times modules that I didn't have. So you can use it at your own risk. I would use it in a virtual environment instead of globally inside of your machine, so that if something breaks, it only breaks inside of the VENV. But apart from all of that, I can't wait to see what the community comes up for this node. You can check out the Discord for this node in the description below. The dev is very active. It's a very small community right now, and the dev has published a roadmap. The most exciting thing about this is that the dev wants to be able to export a solved anynode node as a custom node. So what that means is that in this case, for example, I would be able in the future to export this linear light solution as a custom node. So that's gonna be it for today. I hope you got to learn something new and you get to use this node wherever possible, or at least wherever there's no other solution. My name is Andrea Baioni. You can find me on Instagram at risunobushi or on the web at andreabaioni.com. And I'll be seeing you next week when I will be hopefully publishing a video about preserving details and color matching when relighting people.